So in the last class we have understood need for the regulators. So why we require a regulator? So I was explaining about the stabilizer, right? And I also explained the block diagram of the voltage regulator. So what is the block diagram of the voltage regulator? So it will be having transformer, right? Then comes rectifier, then comes filter, then comes the regulator. So this is the block diagram that we have understood in the previous class, and we have also understood what is the need of it, why we have to go for this regulators. Fine. So now next topic is adjustable voltage regulator. Okay, next topic is adjustable voltage regulator. So how to adjust the voltage? So how to design that? What is the internal structure of it? So next topic would be adjustable voltage regulator. So before going to that adjustable voltage regulator, there is a small circuit in that circuit. There is a small circuit in the internal part of the adjustable voltage regulator. So if you want to understand that circuit, okay, a small derivation, very 5 to 6 line small derivation is there. So if you want to understand this, then you should be knowing what is Ohm's law. Okay, you should be knowing what is Ohm's law and how to write the current equations or how to write the voltage equations. Okay, all those things are required in order to understand the derivation. So let me explain what is Ohm's law. Okay, this Ohm's law concept I have already explained, right? I have already given the definition, also the explanation I have already given before explaining the DAC concept, right? So again, let me go a little bit in depth. Okay, I do not want to explain at that time itself all these things. Okay, as and when required, I will be explaining the concepts, right? So we all know that Ohm's law is given by V is equals to IR, right? V is equals to IR. So how you have got this V is equals to IR? So this is a simple circuit. Okay, this is I can call it as a only one particular resistor has been connected to the voltage device. Okay, voltage source. So now how to write the equation? So V, the voltage across the resistor, will be equal to product of current that is flowing through the resistor and the value of the resistor. I repeat the definition of Ohm's law, it is very important. So the voltage across the resistor is given as the product of current flowing through the resistor and the value of the resistor. So that's what I have written. V is equal to product of current as well as resistor. So current is represented as I1 and the resistor is represented as R1. So V is equals to I1 into R1. Now, can I write the equation for current? If you know one particular equation, then you can easily find any of the quantity by taking to LHS, right? So now I am bringing I1 to the LHS. So how this equation will be? So V divided by R1. Okay. Now if I want to find R1, okay, if I want to find R1, similarly R1 is equals to V divided by I1. So we will R1 has been taken towards the left side, so V divided by I1. Okay, so this is how you can manipulate the equation if you want to find the current or resistor, right? But this is the basic equation or this is the Ohm's law. Okay, I hope you are clear with this particular equation. Next, coming to this diagram, okay, coming to this figure. So there are two resistors. It is almost same like this circuit, but I am connecting the two resistors. Can I add up these two resistors? Yes, of course, because these two resistors are connected in series. Okay, there is a term called series and parallel connection. Let us not go in depth. Okay, let us not go in depth what is series and parallel, because that is already you have studied in electrical subject in the first year. Okay, let us not go in depth. Okay, those two resistors are connected in series, right? So I can write my equation as the voltage across these two resistors is same as current as well as the resistors. But what is the resistor? The resistor is combination of these two. It is R1 and R2. Okay, if these two resistors are connected in parallel, then that will be a different equation. Okay, but since it is connected in a series, I can write it as the voltage across these two resistors. I can write it as the current, the total current that is flowing in this branch into the total number of resistors. Right, so this is equation number 2 with respect to the two resistors. I can also write it as V is equals to I1 just multiplying the current. Okay, I can write like this as well. Next, coming to this equation, these two resistors are not connected in series. How I can tell that these two resistors are not connected in series? Because there is a point here and it has been divided. This end of the resistor is not directly connected here. Okay, the current may come from here as well. So therefore your equation changes. So now what I have written here? The voltage across R1 is V1. The voltage across R2 is V2. So how to write V2 equation? So V2 equation I can easily write it as again the current. Okay? Current into resistor. Right? Current into resistor. But which current you have to consider? Only I2 or you have to consider both I1 and I2? That is your doubt, right? So V2 is nothing but I1 plus I2, because this current will also come to this point. To this point, this current is also coming and this current is also leaving. So therefore, I have to write it as I1 plus I2 into, what is the resistor which is there across V2? It is R2. So therefore, this is the equation for this. Understood? This is the equation for this. So let me assume that I2 is coming here. Maybe it is not visible properly. Okay, if the current is coming like this and if the current is coming from this branch, at this point what is the combination? I1 plus I2, right? I1 plus I2. Okay, so to this branch here you will be getting I1 plus I2. Okay, here from this branch you are getting I1, from this branch you are getting I2. So at this point there is a combination of both the currents, that is I1 and I2. So once I1 and I2 are being added, you have to write the same I1 plus I2 into R2. Right? So this is how you have to write the equation if it is connected in this fashion. Okay, in the adjustable voltage regulator, you will be able to see this type of a circuit. Okay, if you have understood this, then it will be easy to understand the derivation. Okay, I repeat once again very briefly. So Ohm's law is nothing but V is equals to IR, and you can manipulate in this format and you can write the three equations if you want to find the current or resistor. Okay, these are the three equations. Next, similar to this circuit, there is one more circuit I have written here. So R1 and R2 are being connected series. Okay, they are connected in series. I can write my voltage equation as the current into resistor, and I can add these two resistors, that is R1 and R2, because these two resistors are connected in series. Next, how about this? How about this equation? So I have written only for V2. I have not written the equation for V1 because it will be confusing. Whenever the concept comes, I will explain with respect to V1 as well. But for this particular circuit, I1 is coming from this branch and I2 is coming from this branch. Okay. So what will be the current at this point? It will be I1 plus I2. So that current is moving in the resistor, that is R2. So therefore, I will write my voltage equation as I1 plus I2 into R2. Okay, if you have understood this circuit, then it will be very easy for you to understand the adjustable voltage regulator. Okay, so the next concept will be adjustable voltage regulator. Very soon I will write the diagram. So by that time you can copy all these things in order to understand what is Ohm's law